we try to cross multiply such that we have 1 times uv equals to f into u plus v. So in this situation, we're going to have what? 1 times uv, f times this, that's uf, plus what is this? Or fu, because of alphabetical seniority, f comes before u. So automatically you have fu plus fv. In this situation, our interest is what? U. We have u here, we have u here. So what we need to do at this point, we cannot solve this one alone without combining with this. So what we do here is that since u is here, we collect like terms by bringing those u together. So the only way to do that is to transfer this to the other side. And by so doing, you have uv minus fu equals to fv. In this situation now, we now have u and u are common. So what do you need to do? You factorize u. So by bringing u out of this, you left v minus u, and v minus f equals to fv. Then, since our interest is to look for u, we divide both sides by uv. So divide both sides by uv, we're going to have v minus, we divide both sides by v minus u, rather, v minus f, sorry, not v minus u. We divide both sides by v minus f, so we have v minus f, and f over v minus f. So v minus f cancels with v minus f, we have u equals to fv over v minus f. So in this situation, we have succeeded in expressing this u as a subject of the formula. So you can see it now. It's standing alone here, which makes it what? Dependent variable here, because u will depend on the values of the other parameters. Now let's see UTME questions designed for this particular subtopic. The first one says that make R the subject of the formula. So this is what we are given, and we have to make R the subject of the formula. Look at this closely. You will see that R appeared twice as the numerator and also as the denominator. So to answer this very question, we have S equals to square root of 2R plus T over 2RT. Look at what you have. There is a barrier here, and the best way to remove this barrier is to square both sides. We take the squares on both sides. So if you take the squares on both sides, what I'm saying is that we square our S, we also square our 2R plus T over 2RT. We square it. So with this square, remove this square root. Then we have S squared equals to 2R plus T over 2RT. Take note of that. Then this one is a fraction. Let's also make this one a fraction. By making it a fraction, it looks like this. Then the next thing we have to do, since R appeared twice, we have to cross multiply. So by cross multiplying, we have something like this. So you have S squared times this. So we have 2S squared RT equals to, then this one will now be 1 into 2R plus T. So we have 2S squared RT will be equals to 2R plus T. That's what we're going to have. And look at what we have here. We have R is here, R is here. So what we need to do is to take this R to this side. So by doing so, it becomes minus. So you have 2S squared RT minus 2R equals to T. Then R is common to these two terms, so we can factorize the R out. And by so doing, we have R into 2S squared T minus 2 equals to T. Then, since our interest is to look for, is to make R the formula, we divide both sides by 2S squared T minus 2. So that means this one will now become R into 2S squared T minus 2 multiplied by 2s squared t minus 2 equals to t over 2s squared t minus 2. So in this situation, then we'll have this one can cancel this. Then we'll have r equals to t over 2s squared t minus 2. 2 is common here, you can say r equals to t over 2 is common, so we bring the 2 out, and we get s squared t minus 1. So this is now the simplified version of that. That is, r is now made the subject of the formula. Then the second question says that we are given express r in terms of p and q. Where is our r? Look at where we have our r. R appears here. It also appears here. So what do? We have p over root 2 equals to r over r plus q. Everything affected by the square root. What did I tell you? If you want to remove the square root, you square both sides. So p over root 2 all square equals to square root of r over r plus q squared. So automatically this square cancel this. Then this one becomes p squared. Then this square cancel this, you have over 2 equals to r over r plus q. And our interest is to look for what? R. That will make r the subject of the formula. What do we do next? We cross multiply. If we cross multiply, we have p squared into r plus q equals to 2 times r, 2r. Let's open this one. We have p squared r plus p squared q equals to 2r. And since our interest is to look for r, so what do we need to do? What we need to do here is to transfer this one to this other side. Then we have p squared q equals to 2r minus p squared r. Then what do we do next? We try to simplify. R is common here. R is here, R is here. So I can say p squared q equals to r into 2 minus p squared. Then what do I do? Since I'm looking for my r, I will divide both sides by 2 minus p squared. By so doing, I will have p squared q divided by 2 minus p squared equals to r into 2 minus p squared, also divided by 2 minus p squared. This one cancels this, then I will have my r to be equals to p squared q over 2 minus p squared. So I have succeeded in making my r the subject of the formula. To question 3. This question 3, make t the subject of the formula. The first thing you need to note here is that they often or frequently test this question, and you can see JAMB 1992. They often test this question because it is very complex, because of the complexity and the technicality involved. Look at the question closely. You discover that this equation is one of the equations of motion. If you are to solve this question, you can only solve it by resolving to either completing the square method or the use of the formula. The use of the formula is easier than the completing the square method, but it can only be solved by using completing the square method or the use of the formula. The use of the formula is easier than completing the square method. In this situation, you have s equals to ut plus half at squared. Restructure this equation such that it will suit the use of the formula. So the first thing we need to do is to look for the SCM. The SCM here is going to be 2. 2 times s. We use that SCM to multiply each term. 2 times s, we have 2s. 2 times this, we have 2ut. Plus 2 times this, we have at squared. So let's now restructure it. We now have at squared plus 2ut minus 2s equals to 0. Now it is now looking like a quadratic equation where you are going to have t squared plus ts plus s equals to 0. That is what I'm trying to say is that, quadratic equation is of this format. we have 8ax squared plus bx plus c equals to 0. So I want to restructure this one so that it will look like that. Then I have 8t squared plus 2ut minus 2s equals to 0. Now in this situation, what it means is that now if I'm to use completing the square method, I will say that t equals to minus b plus or minus square root of b squared minus 4ac over 2a. That is the formula. So in this situation, that means my a remains a, my b becomes 2u, then my c is now minus 2s. So that's the way we have it. So we come here, c will now be equals to minus b. What is my minus b? Minus b is 2u, that will be minus 2u, plus or minus square root of b squared, so it will be 2u all squared, minus 4. What is my a? My a remains the same. Then what's my c? My c is now minus 2s, everything affected by the square root, over 2a. Then the next thing is to simplify. So I have t equals to minus 2u plus or minus square root of 2u squared is 4u squared. Minus times minus plus 2 times this, I have 8as over 2a. So the next thing I'm going to do here is to say t equals to minus 2u plus or minus square root of 4 is common to this. I can bring that 4 out. I'll be left with u squared plus 2as over 2a. Then here, since you have 4 outside, so it is just like saying t equals to minus 2u, then square root of 4 is what? 2. So that will be plus or minus 2 into u squared plus 2as over 2a.